Well, we're now moving on to our new topic, organic chemistry. In some ways, it's going to be like learning a different language. There's going to be new names and molecules that you'll learn how to draw, but once you get the hang of it, with a bit of practice, you'll get there. So when thinking about organic chemistry, we've got to put aside what we might know about the word organic from our everyday life, about organic produce or organic products. Though there is a connection there through the atom of carbon, which joins them all together, because carbon-based chemistry is what organic chemistry is, and all these organic products that we call from everyday life are carbon-based products. So there is a connection there, but we're focusing on not necessarily naturally occurring things, but things that are based off the element carbon. And these carbon atoms get joined together in chains, and these chains are held together with covalent bonds within those molecules. And also, not only carbon atoms are involved, but also other non-metal elements are connected to the chains through covalent bonds. And these atoms include hydrogen, oxygen, nitrogen, sulfur, and halogens. And it's when these atoms bind to the chain, they, in a specific order or specific way, they end up with things called functional groups. And it's these functional groups that give rise to the chemistry, the different chemistry of organic molecules. And in this course, we're going to look at 7 alkanes, which are like the base unit, alkenes, alkynes, haloalkanes, alcohols, amines, and carboxylic acids. So we're going to start off by learning how to draw them and how to name them and how to classify some of them before we think about some of their properties, and then spend a whole lot of time thinking about the reactions they get involved with. And finally, we apply these reactions together in a couple of different ways. So we'll start with alkanes. Why alkanes? It's because they're the simplest unit of organic molecules. They're like the backbone or the fundamental unit of organic molecules. And that's the reason why is they're just simply made up of carbons and hydrogens held together with single bonds. And because they've got just these single bonds, and they are also referred to as saturated molecules because you cannot add anything to them. And they're also referred to as hydrocarbons because they've just been made up of carbons and hydrogens together. Now, there's going to be special ways of naming these. You can see up there you've got methane, ethane, and propane. How do we get there? Well, there's a group called the International Union of Pure and Applied Chemists, and they have decided ways and rules about how we name things, and we're going to use those rules. And the reason why is it means that other people can be able to draw the molecule you're referring to by the name if you've named it correctly. So we're going to need to know how to name them correctly, and we're going to just follow their rules. So let's with alkanes. First thing we need to do is we need to master this table here, because we only have to go up to chains of up to 8 carbons, but we need to know how we name that. How do we communicate that? And that's with meth, eth, prop, bute, pent, hex, hept, and oct. And good news is, yay, you already know from 5 to 8 from maths. And only ones we need to learn are the first 4. So what do we need to do? We need to work out, when we're wanting to name our molecules, what's the longest carbon chain? And then we correlate that, we'll link that up to the prefix that's in that table there, and use that with the suffix ane, because it's alkanes, to name it. So let's do some examples. So this one here, how many carbons have we got? 1, 2, 3. So that one there is over here. So that one's prop. So this is prop. And it is propane because we're just dealing with alkanes. That's it. This one here, 1, 2, 3, 4, 5. We've got 5. We've got pent. So it's pentane. Now draw one. Butane has got 4, so I've just got to draw 4 carbons, and all other bonds to the carbons are hydrogens. The carbons need 4 bonds. Ooh, it's not a nice molecule there, but that is butane. Now we can get to the formulas of the different alkanes through this general formula. Cn equals H2n plus 2. That will give us the molecular formula. So if we've got hexane, hex 6, so it's going to be 6 carbons. If we plug that into that formula, we are going to get its molecular formula, C6H14. But that doesn't communicate enough about the structure. So we're going to use things called the structural formula and condensed structural formulas to communicate how these atoms are bound together. So for hexane, and the structural formula is drawn out like that. We've got all the C's and the H's connected with single bonds. That's nice and clear, and some students really like that. But we can abbreviate that a little bit using this format called the condensed structural formula, where we can now show that they're there, there's connections there, but without having to draw all these bonds. So those two structures are equivalent to each other. And these are the two that are allowed when you are giving reactions of what's happening, or drawing different isomers, or drawing these molecules. This are the two ways you can draw. We're not going to be using molecular formula. So those were briefly looking at ones that just straight chains. So there was nothing coming off them. But organic molecules are generally more complicated than that. And one way they can be more complicated is that when they have other branches, so carbon chains that get off that main chain, just like a tree with branches off the main chain. And we name those branches the same bit of the prefix, but we add YL, so meth becomes methyl for a single carbon group coming off the chain. Eth becomes ethyl. In reality, we're only really going to be dealing with the first 3 sort of chains. So how do we do it? We've got to find the longest chain and correlate it to the prefix and add the suffix "-ane", and that's exactly what we did just before. Then we've got to identify any branches that were not counted. We count how many carbon atoms are in those branches to find out what they're called, and then we've got to figure out what carbon number they're on, and we want to be able to give it the lowest numbering possible. And we can count from either end of the molecule, and then we write that number in front of that branch prefix in front of the main chain name. So let's see what this looks like in an example. So here we've got 1, 2, 3, 4, 5, 6 carbons, okay? And then we've got this group here, and so it's a 1 carbon group, so it's a methyl, and the methyl, and so we've got 6, so we've got hexane, and I know it's a methyl group coming off there. And now I've got to give it a number. Well, I could go 1, 2, 3, 4, 5 this way, or I could do 1, 2. And the reason why I go for number 2 is because it's the lowest numbering possible. So it's 2-methylhexane. This one here, I've got 1, 2, 3, 4 could be the chain. This way there, it's only got 4. But if I go 1, 2, 3, 4, 5, this is the longest chain that way. And so it's going to be pentane, and then I've got another 1 carbon unit, so it's methyl, and it doesn't matter which way I count, it's 1, 2, 3, so it's on the 3rd carbon there, so 3-methylpentane. This one here is it's a big one, octane, so I'm going to and we've got on number 4 there. Okay, so I'm going to abbreviate this because it's long. CH2, CH2, CH, CH2, CH, to 1, 2, 3, 4, 5, 6, CH2, CH3. So I've got my 8 carbons there, and then I know I've got off the number 4 carbon, I've got an ethyl, CH2, CH3. And that is 4-ethyl octane. We can have multiple branches, not just a single one. And if we've got multiple ones, we need to say what they are, and we arrange them alphabetically in the name, at the front of the name. Once we start counting from one end, we've got to keep that counting. So we can't switch between ends for naming different groups. And if we've got multiples of the same type, we're going to use di for 2 of them, tri for 3, and tetra for 4. And we've still got to say where those are, so we're going to put the numbers with commas between them. So this is an example here. So the longest chain is 1, 2, 3, which is the same as going 1, 2, 3 there as well. So it's propane. Oh, I guess have some room. That's propane, and I've got 1, 2. So I've got dimethyl, and they're on carbon number 2. 1, 2, 3. So it's going to be 2, 2. Hyphen dimethyl propane. This molecule here, longest chain is 6. Let's rename it out for me, but 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yep. And if I go this way, I get the easiest name there. So if I go 6, it's hexane. And I've now got methyls there and an ethyl there. And this, if I start numbering from this end, I end up with a 2, 3, 4. Otherwise, if I went from this end, I'd end up with a 3, 4, 5. So the 2, 3, 4 is the lowest numbering. So I might just rewrite that name. So it's going to be, what have we got? I do it alphabetically based on their name. So I'm going to have my ethyl before my methyl. So it's going to be 1, 2, 3. So it's going to be 3 ethyl hyphen. Then it's going to be 2, 4, 2, 4 dimethyl hexane. So we can already get to a really complicated looking name from what we've just done. Alkenes. Alkenes are hydrocarbons, but these contain double bonds between, at least one double bond between 2 carbons. And it's the double bond that gives their reactivity. And they are known as unsaturated because you can add things to this double bond. The only real difference between alkenes and alkanes is the suffix in their name. So we use "ene" to represent an alkene rather than "ane." So find the longest chain, count the number of carbons to that, the first carbon of the double bond to find the lowest numbering, and you put that number in the suffix for the suffix "ene." So we've got these 2 ones here. We've got 1, 2, 3, 4 carbons, so that is bute. And if the lowest numbering is 1, because if I go the other way, it'll be on 1, 2, 3. And the lowest numbering says bute 1 ene. This one here has still got 4 carbons, it's still bute. And then it's on 1, 2. 1, 2. So bute 2-ene. And so these 2 molecules here, bute-1-ene and bute-2-ene, are known as isomers, which we'll look at in more detail later. They have the same molecular formula, but they actually the bonding is different within them. Finally, alkynes. Alkynes are hydrocarbons, so just with carbons and hydrogens, but now we've got a triple bond between the carbons, and again it's unsaturated, and that triple bond gives rise to its reactivity. In level 2, all we need to know is how to name and draw alkynes. And just like the alkenes, we're just replacing the end of the name with an "-ine" rather than "-ane". So let's see that here. So we've got how many carbons on this molecule? 1, 2, 3, 4. This is bute. And the triple bond is on the second carbon either side, so it's bute 2 and then "-ine". And then here's one for, I'm just going to draw this one for methyl hex 2-ine, so draw that one out. So I'm going to draw it down here because my head's in the way when I'm recording this. So 1, 2, 3, 4, 5, 6. Okay, and then triple bond is number 2. I could draw either side. I'm going to draw it on this side. 1, 2, 3. And then I've got my methyl on number 4. So 1, 2, 3, 4. Now I just add my hydrogens to make sure I've got 4 bonds. With the carbons of the triple bond, I need one of the bonds, and I've got those with bonds to other carbons. There you go. 4-methyl hex 2-ine. And that is what we are doing for the first part, is learning how to name and these different types of hydrocarbons, alkenes and alkynes.